No.
I'm waiting to admit her.
Okay.
Oh.
Are we here yet?
Go ahead.
Okay. Hi, everyone. Welcome back to the Astro Imaging channel. We have a very special guest who stayed up half the night in order to present tonight. But before we go to Luca, I got that name pronounced correctly. There's a couple little Luca.
TS.
I'm sorry.
Luca.
We'll do the best we can. A couple things before we get started. Do we have Marcia in the room? I got to do before after.
She's not here
not
yet.
yet.
I
Okay.
just sent her the email.
So we have some good shows coming up next week. One of our own, Molly, is going to give a kind of a mixed presentation about the Texas Star Party. After that, David Biggs is going to be enhancement of lunar, solar, and planetary imaging. Oh, we love that solar imaging. Rod Palmier, who comes on periodically and always gives a very interesting presentation, is on next. And of course, we have a break for the July 4th holiday. But as usual, we're always looking for presenters. If you have an idea, there's a little contact form in the astroimagingchannel.org. Just go to that, send us a note, someone will get back to you, and you can get on the schedule. And as we always say, you don't have to be an absolute expert. If you have something that's unique that you don't see everywhere, that's the kind of thing we love to have here. Now, we were going to, before we go to Luca, I'm never going to get that right. Do we have Marcia in the room or no?
I don't think
No,
she's
not
here
yet.
yet.
Okay, we don't. Well, let's just go to Luca Bartek. She is going to make a very interesting presentation. Not that they all aren't interesting, but she gave me a little introduction. It's about WBPP, something all us PixInsight users use. And this is a way to make it operate better and to be customizable. Now, I didn't know that could be done, but she's going to talk about that tonight. And I think we're all going to learn just a bit about WBPP. In addition, she has a very interesting background and very enthusiastic about what she does, and is in Switzerland and has stayed up just to talk to all of us. So if we don't have Marcia in the room, we turn it over to you, Luca. It's all yours.
Okay, hi everyone. My name is Luca. I will start by sharing my slides to do my introduction as well. Please just confirm that you guys see it.
Yeah, looks good.
We do.
Okay, that's great. So thank you for having me here. As it was said in the introduction, I will be talking about some advanced ways of customizing WBPP within PixInsight that I think probably all of us use. And this will be done based on two very little known or unknown scripts, which are the event script and the PipelineBuilder script. My name is Luca Bartek. If I don't know if some of us know my work, I am a very enthusiastic astrophotographer, and I also like to share everything that I've learned, similar to the things that I will be talking about today, and also other types of content under the brand or pseudonym, the Space Koala. You can find me on all social media and YouTube, and also my website. And that's where I post all of the stuff similar to the thing that I will show you today. So without further ado, let's get into it. Like I said, we're all familiar with WBPP. It's really a very powerful tool, providing a fully automated pre-processing pipeline. It takes care of the calibration with biases and darks and flats. It does the star alignments for us if you want. It does the local normalization. It integrates your images. It does it based on the weighting parameters that you define. it can drizzle integrate for you, and it can auto crop. It can do so many things. And while it's doing that, in the background, it also takes care of all the file management. It organizes the files for you into neat folder structures. It lets you automatically group your files based on keywords that you can set up. Like, for example, if you're doing mosaics or different targets. And it also automatically handles and saves all the intermediary steps into different files. What more can you want, right? As it does so many things, I think all of us have had the experience that you press the button and then you sit there for hours and hours, and sometimes for days, for it to do all of those things. It is super powerful, but as a result of that, it can take a super long time, as you see it here. Wouldn't it be great if we didn't have to just sit there? Because the issue is, you may just like launch it in the evening, and then you hope that by the time you wake up, you will have your nice master light. What happens sometimes is that there's an error somewhere. Something went wrong in the calibration and nothing was ever done. Or some of the processes actually asked for user input. For example, the local normalization or also the image solving can ask for user input. And if you don't interact with it, it's going to halt the process. So the idea here is, if there is an issue or you need to interact with it, you want to know it immediately so that you don't waste time doing something else thinking the computer is doing it. Wouldn't it be amazing that if you could just launch it, just let it do its thing, and it would kind of text you and say, hey, everything is doing well, I've just registered the frames, or look, we're having an issue, please come and check it out. This is the ultimate dream, isn't it? If we could have some sort of monitoring that lets you do it, so that you could set and forget, launch the WBPP pipeline, because maybe it will run for a whole day, but with the peace of mind knowing that if something should go wrong, you will know immediately. Turns out that with the event script, we can do exactly this. The event script lets you monitor WBPP's progress, and it lets you trigger events based on that. So let's see how this works. Here we have a very generalized flow of WBPP. It's like a loop. So what you have to imagine is, at the top we have available operations. So this whole circle you see here is a single operation. The way it works is, we go into an operation. For example, an operation would be registration or calibration. Those are the operations. And then it will do a series of steps to start the operation, perform most of it, and then do some housekeeping. We will be focusing on the before and after, so these yellow little boxes. If we stick to the example of a registration, we're going to see what happens just before registration and just after registration. Here it says, is it trackable? That means, is it an event that can communicate with our WBPP event script? If it can, that means that we can actually use it to trigger our own action. What does it mean in practice, if it's trackable or not? Here I've listed all of the trackable events. So again, a trackable event means that these are all events that we can get information on as WBPP is running live. So you may have seen that this is essentially all of them. The reason I'm listing them here is because in the background, in reality, it is doing many, many more things, but those are steps that we are not even aware of as end users. These are essentially all the things that we know, and all of these are trackable. What can we do with them? The way the event script works is that we have this environment where we can interact with the system while it's still running, and we can interact with it using these event environment variables. What can we get out of there? Well, of course, we can get the event name. The event name would be something like registration or calibration, all of those things. We can get the event status. Is it still running? Has it finished? Has it failed? Or has it been canceled by the user? We can get the event status message, which would be something like registration was successful for 15 images, or it had a fatal error or whatever. So like something more meaningful. And we can get group information on the events that support groups. Now, what is group information? Whenever you have a group, you can get all of this information listed on the left-hand side that is relating to that group. You can get the size of it. You can get information such as binning parameters, the filter used for the group, the color space, the grouping mode, channels, keywords, and the frames list. If you have the frames list, that means you actually have access to every single active frame in that group. And on the right-hand side, I have listed every single property that we can get from those. This is literally all you could ever ask for. You can get information about everything that you could be potentially interested in. Let's see why this is good in a second. Where is this event script? Because you may have never seen it, but it was actually there hiding in plain sight the whole time. If you navigate to the last tab of the WBPP window, which is the pipeline tab, on the right-hand side of it, there is a field which I've highlighted in yellow here called the event script. What you can do here is you can select it with the checkbox and you can load a file in there. This will be a JavaScript file, and that is actually the event script. That is what's gonna tell WBPP what to do as an event script. So on the right-hand side, I have the simplest possible example, just to give you an idea of how this would work. Here, I will just go through it line by line. If the event is start and we have an active group, then put on the console the event registration start. Then if the event is done and we have an active group, then print on the console event calibration done. Right, so this is very, very simple. Of course, if we were just printing information on the console, that's not really useful, because if you have to read the console, you might as well just sit there at the computer and see what WBPP is doing. But based on this, we can actually do other things in a very similar way. What are some examples of things we can do? Here I've thought of a couple of examples. For example, if you say that for your long-term storage, you store calibrated files, then what you could do is every time a calibration step is finished, you automatically take those files and you copy it over to your external storage device. This is something that you normally do manually, but there is no reason not to automate it. Or you can say, I want to get notifications on my cell phone because I want to monitor how WBPP is doing. You can also interact with other external systems if you want to, automatically send specific files to specific places, and really much more. You can really do anything as long as the one condition is true, and that condition is you want to trigger a specific event based on a trigger that is something that happened in WBPP. So WBPP has to be the trigger, and based on that, you want to do something. Let's walk through an example of how to actually set this up. So I have chosen the notifications to your cell phone. We will look at how we can set this up. Here I have used Telegram. Telegram is messaging service, and the reason Telegram has been chosen is because it is very agnostic of the platform. It is supported on every single platform. It is free, and also it is very, very easy to program with because it has an API, and so therefore it was very simple to interface it with WBPP. Let's see how this is done. We will walk through the code, and as we go line by line, I will explain to you what is happening. We will start out by just telling WBPP who we are and what to do. So for this, we have to tell it two pieces of information, which will be your Telegram bot token, and that tells it who you are, and your Telegram chat ID, and that tells it what is the ID of the conversation on your cell phone, the chat actually, where you expect to receive these notifications. These are two IDs that you have to get externally and then put into the system so that it knows where to send the notifications to. Now we are going to create a function. I don't know the background of the viewers, so to those of you who have a background in programming, I apologize if I tell you very basic things, but for those of you who may not have a background in programming, a function is a piece of code that you can call over and over again just by naming it, and it will execute that piece of code. So here we have defined one called send message to Telegram. And here we just say, when I say send message to Telegram, this is what you have to do. It takes a single parameter, and that is the actual text of the message that we want to send out. And then it takes the URL, that is the identifier of the API, what is the application programming interface of Telegram. So that just says where to send this notification to. And it just specifies a bunch of arguments here containing your bot token and your chat ID, and most importantly, the actual message. This is a very standard way to build one of these called API calls. And at the end, the last line says external process execute via curl. This is the most important line here because this is actually natively supported in PixInsight. So you can actually call all sorts of external processes with just one line, and it supports so many different things so many different ways of interacting with external systems. Okay, so now that we have defined how to send a message, we have to say when we send that message. So we build the actual event script where we will be handling events. We will say, and this you can really write based on your personal needs and interests and to the level of complexity that you would like to have. Here, I've done some very basic examples. We will say if the event is that the pipeline is starting, we will send the message to our phone, WBPP started. You can do many other cases. Then if the event is done, and then we will check what actually happened. If the status is done, that means it was successful, we will send the message. This is the name of the event, for example, registration successfully executed. Or if it wasn't successful, but it failed, then we will send the message registration failed, and then we will also send the status message. And this is that message that will actually contain more meaningful information. It will say stuff like registration failed, could not find star matches, something like that. And here you can really contain as much information as you like based on the things I showed you earlier. All of that information that is available from the environment variables. What does this look like in practice? I will be showing you an actual screen recording from my phone and from my computer. I've recorded them simultaneously, and of course I've sped them up because we don't want to sit here for hours, so you can get an idea of what this looks like in practice, and pay attention because there is a surprise at the end. So I will be starting it now. I have started WBPP, and we are starting with a calibration. In fact, the phone already received the notification that WBPP has started. Calibration is starting with 153 active frames. That was done. Now we're doing the second group with 62 frames. That was also done. Now we have started debayering all 153 images. That was also successful. Now we do the second group of debayering. Also done. Measurements have been done. We have selected our reference frame, and now we are starting integrating all of those images together. This took a while, but not for our recording. And this is our actual integrated image. Your image is ready. So this is something I didn't show you the code for, but actually slightly modifying that function that I showed you earlier, turns out you can even send out a message. So what happened here is we have retrieved the master light stack, and I have done some pixel math to actually auto stretch it. I saved it as a JPEG and I sent it over to my phone. And the reason that this is really nice is because you can be out and about or wherever you are, and you not only be notified that the stacking has been done, but you can get a first look of what the stacked image actually looks like. So you can immediately see if this looks like something really good that you know that you can immediately process, or something went horribly wrong, and then you know that you should expect to allot some time to investigate what happened. So there is really no limit to how many things you can do and the amount of detail you can include in this. But what if we wanted to do even more? We said that the event script can trigger actions based on WBPP's actions. What if we wanted to do the opposite? Let's say that it's not that I want to send the message based on WBPP having done the registration. It's the opposite. I want to tell WBPP what to do and when to do it specifically. If we want to do this, we need to use the second script that I will be talking about today, and that is the PipelineBuilder script. This is a more advanced, even less documented feature. There's actually one forum post about the event script, and there is zero official documentation about the PipelineBuilder script. But you will see that it is extremely powerful, and it lets you fully customize your pipeline. Let's see how this is done. So previously, we were saying that we were focusing on the yellow boxes, so before and after the operation. This time, we will be focusing on the actual center part, the actual operation, because we're going to be telling WBPP, do this and this and this. Let's see how we do it. What can we do with the PipelineBuilder script? First of all, we still have full access to the pre and post groups like we had before, but this time we can add our custom operations. What do I mean by a custom operation? So we said that an operation is, for example, registration or calibration. We can add an operation just like that. You can say, this is what I want it to do, and this is what it's going to be called, and this is how much space it will require, and this is exactly what should happen. And it could even interact with the event script that we have seen before. You can also tell it when this operation should be done. This is super, super powerful. The only downside is, obviously, being so advanced, you also need to write a bit more code, and you need to know a little bit more of coding to actually make use of it. Or do you? Let's see if we can make it easier. What can you do with the PipelineBuilder script? Here, the limit is truly just the sky, but I put some examples here of useful use cases that I could think of. For example, you could do a quick auto processing at the end so that by the time you get to the computer, you have color calibration done and an auto stretch done, so you can have a look at what your image could look like, and you can manage your own expectations as to what you should expect out of that stack. You could do stuff like calibration of background extraction of single calibrated frames. The reason I'm mentioning this is, for example, I know that Cyril supports it, and some people like that. If you have a lot of change in the sky gradients, it could be a good idea to do background extraction on individual frames. You could do downsampling of individual calibrated frames. This is an important example to me because this was my actual original use case. This was the reason I got into this whole world of scripting WBPP, because I wanted to find a way to automate that, because I have this 62 megapixel full frame camera and I was doing this manually. You can do stuff like, I want multi-format output, because while XISF is amazing, whatever other software you want to use after only takes fits. And you don't want to take the extra 5 minutes to batch format convert all the files. You can automate that if you want to do it every time. You can also implement very advanced filtering of the frames before you integrate based on whatever kind of math or filtering you want to do. You can also choose to gather statistics of every single step that WBPP is doing, and then do whatever you want to do with it. And really, really much more. Like, there's nothing you cannot do. Let's see how this works. Once again, we will be looking at the last tab of WBPP. And this is just an example of a run that I did. If I just highlight some rows here, you notice that these are not steps that are present in your WBPP, right? You don't have these custom operations, integer sample, blur exterminator, noise exterminator, all of that, right? These are custom operations that I have embedded into my pipeline, and they have become an integral part of the whole thing. For all intents and purposes, they are just as much part of my pipeline as the native calibration or the bearing. How is it done? We will go once again to the right-hand side of our pipeline tab, and we notice that there is one more field just under the event script we saw before called PipelineBuilder. Works the same exact way. You can hit the check mark and you can browse a file. You can load a JavaScript file, and that JavaScript file is going to try and rebuild the entire pipeline for you. So if we want to do something like this, what we need to do is first we have to declare that new operation we want to add, and then we have to add that operation to the pipeline. And I will walk us through exactly how we have to do this. Bear with me, it will be a bit long, but it will be worth it if we get to the end, I promise. So what we're going to walk through is my original use case, that is adding a downsampler after the calibration step in WBPP. We will start out by declaring our downsampler step. So you will see a lot of the code. We will start by saying stack engine dot, and this is really your way of knowing that you're interacting with the actual stacking engine of WBPP. So here we are interacting here we are declaring a lot of objects that are somehow linked to the native objects of the stacking engine. Here we are declaring the downsampler operation, which will be a function that takes two parameters. First of all, we will take a group of frames, and then we will take a factor. Obviously, the group of frames is whatever we want to downsample. The factor is by how much we want to downsample. We will say that this is based on a BPP operation block, and we will say that this will be called downsampler factor X, so like 2 times frame group, and then it will be trackable. We already know what trackable means. That just means that we can get information out of it using the event script. The next thing we're going to do is we will define the function to calculate the space required by the operation. What is that? We know that before we start WBPP, actually, it tells you, look, this is how many gigabytes this operation is going to use on your hard drive, and this is how much space you have available. In order to be able to do it for our custom operation, we have to tell the system how much space we expect it to take. For 95% of operations, the amount of space it takes is exactly the amount of space that the original files took. But downsampling is a special case because by definition, we're changing the size of the files, right? So what we do here is we take the original size and then we divide it by the downsampling factor times 2. So we divide it 2 times. If you have a factor of 2, then we divide it by a total of 4 because we know that a downsampled image is going to be a quarter of the original size. Once that is done, we move on to the next part. We will be defining the function that feeds information to the event script. This is very, very simple. This is a copy-paste job for the most part. We will say this is the environment for the event script. The name of this operation is downsample. The status is the status of the step. The message is the status message of the step. And the group is the current group. There is really nothing special here. This is a copy-paste operation for every single one of these operations. More interesting is the next one, where we will say what is the main function performing the operation. How do we actually programmatically downsample a bunch of images within WBPP? we will say, okay, so if we are actually running WBPP, let's take the active frames of the current group, and those are the ones that we will be working on. We do some sanity checks here. Do we have at least one frame? Because, you know, if we have 0 frames in the current group, then we're done here. But if we do have some active frames, then of course we have to process them. If we want to process a bunch of files, we have to know where we're going to save them to, so we can set the output folder. This is a good example of how well integrated all of this is into WBPP, because it says existing directory, engine output directory. That is the basic working directory that is set by the user. Then we will say, okay, we will create a folder between that called resampled. And then within that, we will let WBPP create the smart naming folder structure. What that means is we know, for example, if we have 3 different filters, WBPP automatically arranges our files into 3 different folders. This will do that for us automatically. After we have our output folder, we will define the process. This is the heart of the operation, right? We will say that our process P is an instance of the integer resample process. We will say that the zoom factor is actually our input parameter factor, like multiplied by -1, right? Because if we downsample by a factor of 2, then the factor would be -2. We will say that the downsampling mode has to be average, but it's your choice. And here we will say no GUI messages. That is because if you've ever done a downsample before, you know that it comes up with a pop-up message saying, look, you're going to lose all your world coordinate system information, which there's nothing wrong with receiving that message when you do a single image in PixInsight. If you want to do 200 images in a row, that would be a bit annoying if that pop-up message came up. So we're just going to say, look, no messages, thank you. Once we are done with that, we will declare a couple of variables just so we can track how well this is all going. We will say that the number of successful frames as we start out is 0, and the number of failed frames as we start out is also 0. Now we get to actually resampling our frames. We will say, okay, let's loop through the list of active frames and let's apply the operation on them. We will take all the active frames and go through them one by one. We take a frame, we retrieve what is the actual file path of that frame. Then we say, okay, let's open up that active frame into an image window in PixInsight. So we will say, we open a new image window with that file path that we just identified. We check, okay, do we actually have a window? If we didn't manage to open a window, never mind, this has failed. Go on. However, if we do manage to open that window, hopefully, then we have to do a little bit of housekeeping. We know that sometimes an XISF file could contain more than one windows, right? If you have like a rejection map, for example. So what we're going to do is we make sure that we close everything else except the main window. Then we actually execute the downsampling. We'll say, okay, our view of interest is the main view of our window. We'll say, okay, our output file is going to be called the output folder we already defined earlier, plus the current file name and extension. And then we will just add underscore resampled by a factor of 2 to it. So it will be the same file name, just underscore resampled to X. If we actually execute the operation and it's successful, we have a downsampled frame, then we want to save that processed image. We will do a save as, because obviously we don't want to update we don't want to overwrite anything. If we actually manage to save this file, we will tell WBPP, look, this worked very well. The processing has succeeded. And this is the single most important line of code in this whole thing, where it says, processing succeeded, WBPP frame processing step calibration output file. Why is it so important? Because this is what makes it possible for this step to become an integral part of the pipeline. What this does here is it tells the engine that whenever you go on to the next step and you're looking for the successfully calibrated last version of this file, don't take the one that you saw before, take this one. So what it will do is when it goes on to the next step, which will be registration maybe, it will not go back to the original calibrated file, but it will take our new resampled file. And this is how it can be done. And then of course, if this doesn't work, we will say, okay, this has failed. So we do a little bit of housekeeping. Because we have opened the window, we have to close it. So that's what we do. And then we save the step information for the event script in case anybody's asking for information. We will say our status message is, this is how many were successful, this is how many failed, and they were resampled. And if we don't have any errors, we will just say that this was a success. Now that we have done all of that, we will create a new BPP operation block as a prototype for our new operation. Here we just have to declare that our downsample operation is a BPP operation block. And now we have to insert it somewhere in the whole pipeline. Now, do not be alarmed. All this code that you see here is not the stuff that we have seen. This is the entire pipeline of doing all the steps. This seems overwhelming, but we have to find a place to actually insert our new operation. So I have labeled it here. You see the first part, the calibration, and then we have the LPS, we have the bearing, and then the yellow highlighted. That's just the bit of code that we just had a look at. And then after that, it goes on to do all the other stuff. This is really a linear process, as you can see, a single line of code going through many, 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 many lines. So how do we actually integrate our step into the pipeline? Well, we have to actually execute. We actually have to tell the system on which images we want to do this. So what we're going to do is we're going to go through the groups, the post groups. When I say pre-groups or post groups, that is referring to the grouping parameters that you see on the right-hand side of PixInsight. And it is important that we're using the post groups because I have used them for a specific purpose here. We will go through all the groups and see what kind of keywords we use them. So what I have done here is if you define a keyword called RSF, that stands for resampling factor, and you put that into the folder name of your chosen images, like RSF-2, then the system will automatically get that number 2 out of it, and it will tell WBPP, please resample it by a factor of 2. So you put this code in there once, and after that, you can configure it dynamically just by renaming the folder in a specific way, just the same way as you do for grouping other files. If we find that factor and that factor is not 1, meaning we are actually resampling, then we're going to actually call the operation. We will calculate how many pictures we have and how much space this is going to take on the hard drive, because at this point we know how many pictures we have, so we can tell the engine how many gigabytes this is going to take potentially, and then we just instantiate the operation, meaning we will actually call our downsampler operation on our current group with the factor that we just got out of the grouping. All of this is amazing and very powerful, but I think we can all agree that unless you're an actual programmer, it is extremely complex. And I believe that this is the reason that this is a hugely undocumented feature, because most users, unless they're programmers, would not be able to set it up, or maybe they would not be patient enough or willing enough to set it up. So I started thinking, what a shame that we have something that is so powerful, but yet nobody can take advantage of it because it's made so complicated. How could we make this much more user-friendly and easier to use so that everyone can use it? Enter the no-code pipeline builder. That is the pipeline builder script for the rest of us. I have built a way for us to be able to do all of the stuff we have done before without writing a simple line of code. In order to do it, I had to come up with a way to tell WBPP what are the processes we need to do, and I had to find a way to do it that is understandable both by ourselves, the end users, but also by PixInsight. And the clear solution was process containers, because that is exactly what they do. They contain a list of processes. We know how to use them, but WBPP also knows what they are. So we have a framework here where we can define a process container, put a bunch of processes in there. We have a list of predefined entry points where you can actually put those processes in to the pipeline builder. And it can even support more advanced filtering of when you want to do it, such as based on grouping keywords, and all of this without any coding whatsoever. So let's have a look at how this works. On the left-hand side, we have a process container. You see that it actually has a description field, and we will use this description field to actually tell the system when the processes should be applied. So if we zoom into that, it says the step should be on calibration end. So obviously when we're done with calibration. And you can have a series of other keywords here, and there you can just filter for the grouping keywords that you have used. In this case, I used cam equals 6200 mm because I like to group based on the camera that I use. So what are these predefined entry points where you can add your custom processes? Well, you can have it on calibration end or on the whole pre-process end. You can have it on post-process start, registration start end, integration start, and finally on post-process end. You will see on the right-hand side that if the step is linked to an actual step in WBPP, then of course we will only execute it if that step is actually happening. There's no point doing something on registration start if you're not registering. However, the three that are more generic on pre-process start end and post-process end, those are always executed. How does this actually work? We have to look at the hierarchy rules. We have to name the process container WBPP, because you may have 15 process containers on your desktop. It has to know which one it should take the instructions from. If the key is present on a process container, then all of the processes underneath will inherit that value. And if the key is then redeclared at a lower level, that will override any inherited value. So let's see how that works in practice. On the left-hand side, you have the tree structure of a process container. It contains a single process integer sample, and then it contains a nested process container where the description says on post-process end. So what happens in practice? The integer sample has its own description on calibration end, so obviously that is when we're going to do it. The process container underneath has the description on post-process end on container levels, so everything within that inherits it. What happens if we say that we just move the description above? Actually, the same thing, the outcome is the same because of the inheritance rules. When do we actually apply the key value pairs? So a process will be applied at a given step if it has the corresponding step value, meaning I think it's very logical. If the process says on registration start, we will apply the process on registration start. A process is applied on a group if it has all the keywords specified on the process. If you're using groups, obviously, we're only going to apply the step on the groups. if a process applied to a master will be applied to all the available master variants. So this is the special case of the very, very last step, because if we have already integrated the images, then there is really no point doing anything to the individual frames after that. So in the very last step, you can actually apply steps on the generated master. And since we have no way of knowing which master variant you're interested in, we will just do the process on all variants. So if you have a regular or a drizzle or an auto crop version and so on, we will just do it on all of them. What if you want to do further filtering? Of course you can. You can see here that on Blur Exterminator, I have specified an additional filtering criterion, cam equals ASI 183 mm. So the Blur Exterminator will only be done on the groups with that value for that key, whereas all the other steps will be done for all the frames. We are done, and finally we can have a look at what it looks like in practice, because you will see that this is really much simpler than what you could be thinking based on the presentation. So I will be looking through this process container I've set up here. So I'll walk you through how it is. We have integer resample there as the first step. It has step equals on preprocess end. And here I'm just drawing your attention to the fact once again that we have no GUI messages because we don't want 200 pop-ups. Then we have our nested process container. So we have all the examples we have looked at before. It contains a bunch of steps. So on the head level, we have step equals on post-process. And what this means is I want to do all of these steps on the masters. I'm going to do blur exterminator. I'm going to do noise exterminator. I'm going to do spectrophotometric color calibration. Here, I'm just walking through all the parameters. Here, I have disabled everything that results in a pop-up. Then we have the automatic background extraction. Also here, we don't want any extra windows popping up, and we want to make sure that we actually overwrite the image that we're calibrating. Then we do a pixel math that is just an auto stretch, and we do some curves transformation that is just some contrast and saturation. So let's actually see how this works. I have a bunch of images. These are color images. Note that we have astrometric solution active because otherwise color calibration is not going to work if we don't have a solved image. And then we go into the pipeline. You see that all of the steps from the process container are automatically already propagated here because we have the pipeline builder active. We have all of those steps that we have seen before, so let's just launch it. Here we can see the progress of the whole pipeline. We have done calibration, debayering, blah, blah, blah. We are currently doing the first custom step, which was the resampling. We are currently integrating. Then after the integration, we will do the astrometric solution of the masters. Should have sped this up more. And once the astrometric solution is done, we will take all the masters and we will do all of the steps that we have defined in the process container, and that is done. So let's have a look at what actually happened. I will open up my file browser. And here, so we have the debayered images, and I'm just showing you that these are 300 megabytes. And the on preprocess end, those are just 78 megabytes. So we know that the resampling worked. So we're working on those images afterwards, the resampled ones. Let's have a look at the regular master that WBPP spat out. I'm going to open that up. I'm just going to auto stretch it.
Can I ask you a question? I missed a step. How did you link the process container with WBPP?
The process container has to be called WBPP. And then when my pipeline builder is loaded into WBPP, then it automatically looks for a process container with that name.
Okay, thank you.
Okay, I don't know if I can scroll forward in the video to where we were. Yes. Okay, so we were exactly here. I will open up the master, that is the regular stack of WBPP. I will auto stretch it. This is just the stack as it comes out from WBPP. And now let's have a look at our version with the basic auto processing. I open this up. You see that this is already permanently stretched. This is color calibrated. This is, blur exterminated. We've done all the magic on it. And I think the only thing I might want to do to this is actually just rotate it, because in the Northern Hemisphere, we're very much used to the horsey looking upright. And then, for all intents and purposes, we have an image that gives us a very good idea of the data that is actually in our image. I mean, some people might actually be happy with this level of processing, but I mean, if you're not, I'm not endorsing auto processing, but it is extremely useful because you can just go back to your computer when WBPP finished and see what is there in your data, what you can expect out of it. So what do we do if we want to get started to get your WBPP to the next level? Everything that I've showed you here today is available to download for free from my repository. Everything is listed on my website. I have written extensive documentation with instructions on how to use both of these scripts. Since the original Telegram notification event script, I've actually improved on that further. So now you don't have to modify the script even with your token anymore. There is a configuration script, and you can not just configure it to send notifications to Telegram, but if you have a Mac, you can also send notifications via iMessage to your iPhone. And with the last update, you can now also send notifications via pushover. So you can set up which is your preference, and it will do it automatically. And you can also download the actual PipelineBuilder script from my repository. And all you have to do is set up the process container called WBPP, and the whole thing should work. Of course, the use case of me showing all of this is not just to, tell you to use my stuff, but also because these are highly undocumented features, and I really hope that this gets the word out, and some people out there who are creative or better coders than me can work on it further, and you're very much encouraged to use my code and, work on it and get it out to the community again. Generative AI and large language models can be very, very helpful in writing code, but this is something very, very important that I have to mention. The PixInsight license that we have does not allow us to take any PixInsight code and paste it into ChatGPT or Gemini or whatever you choose to use. If you don't want to breach your license, please don't do that. But it doesn't mean that you cannot use them. It is just very important that you go into the settings. Here I have a screenshot from ChatGPT. You can actually go into the settings, and there is a setting called Improve the Model for Everyone. Just turn that off. What that means is you can actually paste whatever PixInsight code you want, and it will not be using that conversation for improving the model. This is very important that you do it. It is in everybody's interest, because if we get the code out there, then PixInsight developers will choose to just close it down, and we will no longer be able to have access to the source code as we are today. With that said, I am done with the presentation here. I hope that you found this helpful. If you have any questions or comments, now is the time. I'm very, very happy to answer anything. So feel free to ask away.
You can stop sharing if you want, Luca.
Okay.
I think we were all trying to kind of keep up, and when you got to the more automated object kind of process container, I think we all breathed a sigh of relief. Because I don't
Yeah,
think
that's
we're
the
all
thing.
close.
You really have to kind of build it up, because otherwise it's not as impressive, is it?
Well, let me ask you a question. A lot of those functions that you're in the process container, they're all customizable, and I don't know about the rest of PixInsight users, but with each stack, with each master, I'm kind of experimenting with what to do and what is best. So there is no one way to use blur exterminator, noise exterminator, or especially with the background correction. I mean, that is really a customizable tool. How do you accommodate that in the setup that you have in the pre-process container?
Okay, so first of all, let me just preface it with I fully agree. And I think I even mentioned I'm not endorsing auto processing because you're never going to have the right results. Throughout I kept mentioning this is just, in my opinion, this is just for you to have a first look at what is possible. But I am conscious of the fact that a lot of people out there do want to do the automation as much as possible. I fully agree with you, and I wouldn't personally use it for the processing of what will eventually become my final image, even though there are things that you could do automatically. For example, the first step is likely going to be color calibration. So that is something that there's no reason for you not to do in an automated way, right?
I
And
agree.
for some people like to have a very fixed workflow, and if what they do anyway is to drag the same process icons over to the same to all the images in the same order, they might as well automate it.
Can you use the latest background correction? What do they call it? CGA or something?
The
Multi-scale
Mars
requires-
phase one.
the multi-scale gradient correction.
Yes, multi-scale gradient,
Okay,
which requires
so
2 steps.
yes, so those 2 steps are 2 separate processes. So what you could do is you automate spectrophotometric color calibration, spectrophotometric flux calibration. Those
Mhm.
are going to be fixed. And what I would do is I would do them in an automated way. And then I would go in and do the actual gradient correction myself, because that is a step that is much more delicate and you want to have better control of what you have. Of course, the system has limitations because it will only work well for things that require no user feedback. It works with processes, not with scripts, for example. And also with the processes, there are just some ones that are not going to be good. So I think that's the case also with, theoretically, it would work, but I wouldn't recommend it because it is a bit of a trial and error.
Alex, there a question out here from Chris?
Well, I've been watching the whole thing, and actually we had a few comments about how fascinating this whole thing was. One guy called it "This is fire." Anyway, wow, this is fire. John at Astra said, and Chris Kagi has the same thoughts going on in his head, and I went ahead and asked it in the comment section. It looks like you're using the parameters for all the parameters are set the same for all images. And I think that's the discussion you just had with Eric, is that may not be appropriate for a quick way to judge how everything's coming out. And actually, if you're satisfied with it, you're good. This is good. But my larger question was, can we pretty much take the default parameters that we've been given and get a pretty good image? What's your viewpoint on that? I think if you have anything more to say than what you just said to Eric.
I think this question is not even related to my pipeline builder. This is a more generic question. Are the default parameters good? I think that the default parameters were set in a way that they are most likely to work with the largest number of images. And I think that they will create decent results for most images, but they will
Mhm.
never create the ideal result for any image.
Okay.
So what's the next step? I mean, you must have what comes next for this.
Oh, for me, I would love to make it work also with scripts. So by the way, this auto processing is just something I did because for the demo, it is very, very, visible. But like I said, my original use case was the downsampling. So I did it because I wanted to do that, because that was something that I used to do manually every time. Yet I know you're going to ask me, why don't I just bin to? The reason I don't bin to is because I want to be able to decide later on if I'm going to bin to or not. And also I have my very nice super bias that I've taken with, 1,000 bias frames. I'm not going to do that with every pin combination. So this is the reason I came up with the whole thing. And then it just kind of spiraled into how freaking painful this whole thing was to code. So, if I have the patience, other people are not going to have the patience. There has to be a better way of doing it. And since this went live about 2 months ago, I've had some feedback from some users. I know that there are some people actively using it. And, not necessarily, most of them are not using it for the auto processing. They also have these very, very niche use cases that they want to do specific things at specific steps. And that was just not possible before.
The other thing I noticed you were talking about WBPP taking 6 hours. That seems kind of unusual. I mean, I do bin one with a fair number, and an hour would seem like a long time.
I mean, I think it depends on a lot of things. It depends on the speed of not just the processing power of your computer, but also the speed of your hard drive, because it's constantly reading and writing files. It depends on the number of your images, because the problem is that a lot of the steps are not linear as the number of images grows. For example, integration, it's not like if 10 images takes you 10 minutes, then 20 images is going to take you 20 minutes. If 10 images are 10 minutes, then 20 images are going to take you maybe 40, because it is increasing exponentially. I usually integrate hundreds of images. So, and actually, I'm not even complaining about how long it takes, because my computer is relatively fast. But just reading forum posts in the community, you do see people complaining, especially if you do drizzle narration. And if you do local normalization on a lot of images, that can take you a really long time. They have these community projects where they get like 10 people together and they're all shooting the same galaxy. And at the end, they have terabytes of data. Somebody then has to integrate all of that together. And that takes literal weeks.
Alex, is there more pop-ups on?
Chris Kagi is asking that when Luca showed her example of nested processing containers, Luca, did you have to create 2 process containers and then drag the nested one into the container named WBPP?
Yes.
Okay.
Okay, yeah, I was curious about nesting too. I don't think I've done that before.
And that, I think, is all that we got. So that.
Well, that was fantastic. Again, I have a bit of a headache trying to follow that, and I was hoping there wouldn't be a short quiz after the end of it, because
Yeah, I think this is a rewatch one. This is, you're going to have to
Yeah, I
rewatch it a
hope
few
people
times.
didn't fall asleep while I was running through the lines of
No.
code. But I think it's also useful for the 1% of the people that want to do their own stuff to have an actual worked out example, so they can see why we do each of the steps. Because if you just miss out one of those steps, it's not going to work. I would know, because I was struggling for a long time to make it work.
well, you put up your site so people could go to the site and they could download and have a little more instruction.
Yeah.
The number of users actually climbed through the show, which was great.
Oh, wow.
Yeah.
Yeah, so you have between 50 and 60, but I bet when you come back in a week or so, you'll see a lot more people viewed it on YouTube.
Yeah.
I'll have a look at the comments later on in case somebody has questions.
Yeah, definitely.
And you can answer them.
Um,
Well, is there more, Alex?
yeah, no, well, I want, if anybody else has any more questions, please put them in for a minute here. And I'm going to give you a chance to do that, because you might have noticed earlier on in the comment section, Molly, Marcia, and I were having a conversation, because Marcia just wanted me to remind you all that she is planning on working on a presentation for the Astro Imaging channel about collaborative imaging. And she is looking for some people who could collaborate with her in making that presentation. You can get a hold of us by going to the Astro Imaging channel and using the contact sheet there, and I will make sure that Marcia gets a hold of your name. And since I've got the microphone right now, I should remind you that we need presenters. you can see that the calendar doesn't have a lot of names in it. So we really need your help if we want to keep this thing going. So please, if you're interested at all in giving a presentation, please go ahead and sign up with us using the contact information on the website. Now, that was your time to get in any further questions. As I'm sitting here reading the screen behind the microphone, I don't see that there's any, actually,
I think we're all set.
Yeah.
Also, while we're
Lucy?
making pleas, we do need a couple of volunteers to come work on the show as well. We need a streamer or two, and we will teach you how to do that and provide that software. And we also would like to have somebody to monitor and work on and improve our social media presence. So if anybody's interested in doing either of those two things, please go to the astroimagingchannel.org, hit contact us, and let us know.
Yeah, and it's a lot of fun to come here on
Yeah,
Sunday
you
night
get to be
and
here
do-
in the room and chit chat and ask questions.
Lucia saying, yeah, you're chit-chatting. It's 2 o'clock in the morning or 3. What time?
I wish it was 2 o'clock. It is 4:30.
Oh no.
4:30.
Yeah, so it's hard to go
All
to
right.
bed. You might as well just stay up.
Yes.
Well, again, Lucia, thank you very much for presenting tonight and for staying up late for us. We all appreciate it. And I think we've come to the end of our show. Molly, you're the streamer tonight.
Yep, that's right.
All right,
All right.
then take us out.
We'll do.
So,
Good night, everybody.
Good night, everyone.
Bye,
We'll hopefully
everybody.
see y'all next week.
Bye.
Lucia,